Yesterday afternoon, from this very spot in my driveway, I made contact with NASA astronaut Kjell Lindgren, who was flying overhead on board the International Space Station. I made the contact using my ham radio equipment, which I'll show you here in a moment. Contacting the space station can be fairly easy in terms of the distance involved because it's overhead, it's line of sight. So basically any radio that can do VHF and UHF FM, which is a lot of radios that hams own, can do that kind of contact. The radios sometimes will have just a little rubber antenna on them, and you can talk like this. If there was nobody else on trying to call the space station, and you were the only person on the ground, they would probably hear you fine. But in the case of ham radio and the ISS being so popular for hams to try to contact, what most operators do, like me, is they either have large stations in their homes with remote control beam antennas, or they do what I do, which is to get a relatively inexpensive handheld beam, and I stand out in my driveway, I connect it to my equipment, I point it up to where the space station is, and I try my best, and I start talking. The contact I made here was the first one I've made in about 12 years, so it's not very easy to contact the International Space Station on a random basis. What happens is, of course, the astronauts up there all have jobs to do. So while some of them like to drift over and play on the radio once in a while, they have a very tight schedule of experiments and other kinds of measurements that they have to do up there, and they're up there for 6 months at a time, some of them. And in the case of this particular contact and several others earlier this week, astronaut Lindgren had a little bit of free time, so he could fly over inside the module to the radio position, and he just got on and started talking to people randomly. Lucky for me, I was one of the people that managed to contact. So there's another pass coming up today. I'm going to try again, just for fun, and this time I hope to take you along with me. But first, we'll talk about the equipment that I have. It's fairly basic, but it takes a while to assemble. The radio I use is an ICOM 9700. See, I got that. One that does FM, AM, single sideband, Morse code, digital modes, all kinds of things. And it's a great radio for me to contact the space station with because it has transceivers in both the VHF and UHF range that can operate at the same time. One of the neat things about operating into satellites is that sometimes you want to be able to talk and listen at exactly the same time, so you can tell whether your signal's making it up to the satellite or not. With the space station, that's not really my big concern today, because when I'm talking, hopefully he's listening and he'll be responding to me or to whoever else is able to call him, if he's even on the air at all. I keep my 9700 in a very secure case, similar to a Pelican case, and with it I have a headset, I have power cables, and a few other accessories that makes my ability to operate for space communications that much more effective. Now, my particular radio doesn't have batteries of its own. Some of the smaller ones do, but mine doesn't. So that means I have to provide power to it. And a lot of the times when I'm operating, especially working satellites from a good location that has a good horizon, I can't do that from home necessarily, although I'm going to try that today. I can't do it from home because there's usually obstructions in the way. So I want to be able to drive to a place that's like a large parking lot or a large field where there's not a lot of things in the way of my view of the sky. That means I have to have portable power. So I use a small portable power bank that I charge in my home or charge with a solar panel, and I run the radio off that. I don't use a great deal of RF output power in the radio, so the power bank can actually power the radio for quite some time before it needs to be recharged. So here's the 9700 with things plugged in, everything except the antennas. I've got the external power jack right there, and underneath it there are two smaller plugs that are in. One is to control the frequencies of the radio, which I'll explain shortly, and the other is for a Morse code key. And the key is just a little magnetic thing that is sitting up on top of the radio, and here are two paddles on top that I can use to send the dots and the dashes of Morse code. Although I don't expect to use Morse code today, I'll hook it up anyway just for demonstration purposes. The antennas that plug into the back of the radio, I'm using little adapter connectors to adapt the existing ones to what we call BNC connectors, which are easy, quick connect and disconnect connectors that will go towards my antenna. This one again is for 2 meters or 144 megahertz. This one is for 70 centimeters or 435 megahertz. Now in my case, the antenna that I'm using today is called a log periodic, and it works on both bands at the same time. But since on the radio I can't connect both antennas into the one connector at the same time, I have to use another device called a diplexer. Now the diplexer in this case is an MFJ 916B, just a little box, and two antennas connect on this side of it, and this side goes straight to the antenna itself. So my 70 centimeter cable would go into this one, my 2 meter cable into this one, and I'm going to connect it now. Now you may remember me mentioning that I needed a device to control the frequency of the radio. This is because of a thing called Doppler Shift. When something is traveling through space, it's going at 17,500 miles an hour in a normal Earth orbit. And that speed is so fast that when it's transmitting a radio signal, the radio signal is arriving at your location at a certain frequency plus 17,500 miles an hour. So it appears that the radio frequency is actually a little higher than it really is. Conversely, when the space station or satellite is heading away from you in the sky after it's been overhead, it's now departing your area at up to 17,500 miles per hour. And that means the frequency striking you on your antenna is that much lower than it really is. Plus, to add a complication to this, when I'm talking to the space station, I'm using the 2 meter band, or 144 megahertz. When the space station transmission's coming back to the ground, it's coming back at a frequency of 437.800 megahertz, which is a lot higher. And just because of the math, Doppler shift affects higher frequencies more than it affects lower frequency. So not only do I have to adjust the frequencies of both my receive and transmit on the radio, I have to do it at different rates because my receive is on 70 centimeters and my transmit is on 2 meters. Therefore, the radio needs to be tracked very carefully, and that's far easier to do if you have an automatic device doing the tracking for you. The device I have is called an SatBox, and it's from a company called CSN Technologies. It's a couple of $100, it's not a whole lot of money, but what it does is it logs onto the internet and finds out all the orbital data for everything that you want to track in the sky, including the space station. When I want to use it with my radio, I plug the back jack of the radio into this unit. It's made specifically for my kind of radio. And then I use a simple USB power connection to get the thing to turn on. And there it goes. It's beeping to let me know that it's on. And right now it's looking for a Wi-Fi internet connection to link up to. And very shortly I'll be able to configure this and have it tune the radio for me, so that's one of many less things I have to worry about if I'm trying to make a contact. Now the SatBox is already on, and I'm tracking the ISS. See where it says SAT ISS. Acquisition of signals at 9:56 my time this morning, or 9:56 standard time, 10:56 daylight time, so that's in about 6 minutes. And the azimuth of the space station currently is at 270 degrees, so it's due west, but it's below the horizon by 21 degrees. Now the SatBox is still connected to the radio as if I could see the space station, and obviously right now I can't. And the station is tracking the top frequency is the frequency I will be transmitting on, and you'll see it's changing but not very much. The bottom frequency is the frequency I'll be receiving the space station on. Actually, they're not changing hardly at all right now because the space station is still over the horizon. But once it gets into the sky, those frequencies will start changing much more quickly. Now, how do I talk to the space station? Well, of course, there's a microphone involved, so I'm now going to plug in my microphone headset. Although the radio has a regular microphone that you would use in a push-to-talk situation, what I prefer to use when I'm doing any satellite or spacey things is a headset, which has the microphone and the headset all in one system. Now normally when I would use that, I would wear the headset, I would plug the microphone and the earphone jack into the radio, and I would hear what I'm doing and I could talk, and nobody around me would hear anything. But that wouldn't be very fun. So at the very least we're going to try to listen to the International Space Station as it goes over. So I'm going to leave the headset part unplugged so the speaker on the radio will actually transmit the audio that we'll be receiving. The other thing I need to do is tell the radio when I want to transmit. So I have a remote push-to-talk button, and this is one I use sometimes when I'm flying or when I'm around the airport, so I can push to talk and engage the transmission of the radio without having to reach for a hand microphone. So right now the radio is turned on. The space station is getting very close to rising in our western horizon. It's going to pass due north of us and then it'll go away in the eastern horizon, and we're going to see what happens. Still recording, right? I think it is. November Alpha 1 Sierra Sierra, Victor Yankee 2 Hotel Foxtrot, VY2HF. Got a lot of happy hams down here, Shell. Thanks again. VY2 Hotel Foxtrot. Name is Brent.
VY2 Hotel Foxtrot, thank you so much. It's a privilege to be up here and a privilege to get to contact you all.
It's great for me in Atlantic, Canada, because now that you're over the ocean, I have you all to myself. And 7-3, and again, have a safe flight home.
7-3, and thanks so much for the best wishes.
So there you have it, proof that this thing isn't easy. Yesterday was the first time I contacted the space station in 12 years, and it may be another 12 years before I contact them, but I was a little over-optimistic to try to presume I was going to get them today. But you never know. He has been on several times in the past 6 or 7 days. In particular, Kjell Lindgren, who's there's several astronauts up there, but Kjell seems to be the one who likes to play on the radio. The chances of him being on 2 days in a row pretty slender, and they just weren't on at all. It wasn't that I couldn't get into the space station. They were over us and about 30 or 40 degrees high in altitude as they went past, traveling a couple of 100 miles up, obviously. But if the space station's transmitter and receiver had been on the air, I have no doubt that I would have heard them at the very least. I may still not have put a signal into the space station, but I certainly would have heard them. But I listened on a couple of different frequencies, and they're not on at all. Oftentimes they will turn the radio off on purpose if they're having a docking or an undocking or doing some other special operation inside the space station. They will turn the radios off just to avoid any potential for interference. That could be what's going on here. Or maybe it's Father's Day and they just want to take a break. Anyway, thanks for coming along on this, and I'll try to film the next time I work the International Space Station.